And then the domain of a function is the range of its inverse. So think about what we do when we find the inverse. We switch our x and y coordinates, right? So we're switching the x and y. So it would make sense that all of the domain, which is my x's, becomes my range, which is my y's over here. So what you're going to see that I'm going to give you some on the test for this is that I will ask you to find the domain of the inverse of a function, but I will only give you the picture of the function. So I won't give you the picture of the inverse. I will give you the picture of just the function that I'm talking about. So here we've got f of x equals x minus 3 to the second plus 5. So this is the function of f of x. Right, so let's talk about domain and range for the function that we're looking at right here for our f of x. So we're dealing with a quadratic here. Let's see, Hallie, what is the domain of that quadratic going to be? Very good. It's going to be negative infinity to positive infinity. Because I can plug any number in. These are going to go out in that direction forever. Grace, what about my range for that function? Okay, so range, we're talking about y values, right? So we're thinking about what's the very, so like for x, we're thinking about what's the very lowest x I can put in and what's the very highest x I can put in. Well, these keep going on and on and on and on forever in this direction and on and on and on and on forever in this direction. So you could go all the way out to the ends of the infinity, right? But if we're thinking about y's, we're thinking about what's the very highest number I can have and what's the very lowest number I can have. So when we ask that question, what's the very lowest number I can have for the y's, is there an answer to that? What's the lowest number you see here? 5. 5's the lowest we can go, right? So we can include 5 because it's actually defined at 5. There's not like a hole in the graph there. It actually touches 5. So we would use 5 as our lowest number. And then we're asking ourselves, what's the very, very highest y that I can have? And these two, both sides are going to go up, 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 up forever, ever. So that is going to give us infinity. There. So this is the domain and range for f of x. Yes. Yeah. No, you would still include that. So it's okay if it equals 0. You just can't have zeros in the denominator of a fraction, which is usually going to like cause a vertical asymptote or something. But it's okay for the function to equal 0. So you could include 0 for domain and range. The only time you wouldn't do that is if it was asking you like positive or negative or something like that. So for domain and range, we've got that here. But the question didn't ask us about domain and range. It asked us the domain of the inverse of f of x. So the question asks us about f inverse of x. Here's the cool thing. If you can find domain and range of the original function, which we've already done some, but we could probably still use a little practice with, right? Then inverse is super easy, because if you did the first part right, here's all you've got to do for domain and range of the inverse. Just switch them. Domain is going to be 5 to infinity. Range will be negative infinity to infinity. And so this particular question asked for domain, so we would circle that as our answer there. Now, certainly we could find the inverse. We could switch our x and y's. We could solve it. We could do all of those things. But if we do, it's going to take a little bit more work. And whenever I give you these problems, I will give you a picture, but it's going to be the picture of f, not of the inverse. So you have to read carefully whenever you're doing this. Okay, questions? And if I switch my x and y's here, just so you can see what it looks like. You can see how the domain changes from very furthest you can have on this left-hand side on the x is 5 to infinity, whereas up and down here you'll have negative infinity and positive infinity. All right, so let's do a couple more of these. So let's look at this first one. Actually, let's do it without the graph first and then see if we're right. I'll probably give you a graph on these. I'm pretty sure that I gave you a graph on these on this test. But let's try it without the graph first. So let's just look at the domain and range of f of x. So we're not talking about the inverse yet. We're just talking about f of x. So just looking at my equation, what is the domain going to be? What do you think, Hallie? We can include a positive infinity if we use that, but there is a restriction. There's something it cannot be. What could we not have? We cannot have 3, right? I like to write it like this. Just x cannot equal 3. But if you use interval notation, it would be negative infinity to 3 and 3 to infinity. So we're just getting that from that denominator. Whatever the denominator is cannot equal 0. So x cannot equal 3. Okay, all right here. All right, this is a little tougher without the graph. Who can tell me the range of this one? It is going to involve that 9. But if we think about what a rational looks like, let me graph over here just the f of x equals 1 over x, like the basic rational function. Basically, you're going to have a vertical asymptote. You're also going to have a horizontal asymptote. So a lot like your domain range, you're just going to have like one number that it can't be. So think about what's happened to this graph. 4 is going to cause us to have a vertical stretch, right? Stretches and shrinks do not change where your asymptotes are at. So the -3 moved this over to the right 3. And so where I was right here at 0, it moved it over to the right 3. So what's going to move that horizontal asymptote? The +9, right? So it's going to take this right here that was at 0, and it's going to move it up 9. So, so what we're going to have is that x cannot equal 9, and it would be negative infinity up to 9. So that was the part that you were missing, Blaine. And then 9 to infinity is the part that you had, right? So it would be above and below 9. It just can't equal 9. And if we graph it, because you'll probably have graphed this. You can see that that looks good. You could even type in x equals 3 to see, oh yeah, that's my vertical asymptote right there. You could type in x equals 9. And, oh no, don't type in x equals 9. What did I do wrong there? Y equals 9. And you can see you have that horizontal asymptote there. Oh! I've messed up again. What else have I done wrong? This happens to me a lot. Something else that I've written up here is incorrect. What is it? I should have y does not equal 9 because range is y values. When you do interval notation, it doesn't matter because you don't actually include the letter. But I should, for range, I should have y's. So this is the hard part. Then the inverse is really easy because you just got to switch them. So the domain of our inverse. Now, you do want to switch a letter whenever you do this. So the domain is going to be x cannot equal 9. And range is going to be y cannot equal 3. So make sure when you switch, the domain always has to be x's, range always has to be y's for that. Okay. We're going to do the same thing with number 3. We're going to try it without the graph, and then we're going to look at the graph to make sure that we did it right. So, with f of x, let's see, Noel, for our domain, if we don't have a graph and we have a square root, what do we have to do to find that domain? Very good. So x minus 4, what's underneath that square root has to be greater than or equal to 0, which is going to give us x is greater than or equal to 4. Or you can use interval notation, bracket 4 to infinity. Okay, let's talk about the range without the graph. For our range, normally square root looks like this. We moved it over to the right 4, which is going to make it look like this. Then what else is going to happen to that graph there? Flip. We flip it over the y. Actually, the reflection is going to happen first, actually. Then it'll be moved, so it'll look like this. So, I'm sorry, wrong way. I did y-axis. It's going to flip over upside down, so it's going to look like this. Right, let me use it. So, if it's upside down, what is the very lowest y value we're going to have? Negative infinity. What's the highest y value we would have? 0. So, we would have negative infinity up to 0. We include 0 because for a square root you include that. And we can graph it to check and make sure that looks right. And you can see that looks like our little sketch that we had there. So it's good to be able to do that even without looking at the graph. But sometimes you might need to look at the graph to verify. So that's the hard part. Inverse is easy now that we've got that part, right? So inverse, domain, and I could have also written this, I guess I should write it this way. Y is less than or equal to 0. So domain is now going to be x is less than or equal to 0. And range is going to be y is greater than or equal to 4. Or we could write negative infinity to 0. Or we could write 4 to infinity here. And on Desmos, you can check it with your graph too. If it's on the Desmos section. If you switch your x and y's, you don't even have to solve for it. You can kind of see what happens here. You can see, oh yeah, the lowest y value I've got is 4. There's my range. So domain, you can see it stops there. Negative infinity stops at 0. So you can use that to check there. So this one was asking for domain right here is our answer. I didn't circle my answer here. I hadn't been asking for range, but I could ask for range. Also, domain is going to be our main focus because domain is really important for that. Let's do some composites because we're going to run out of time here. So I'm going to skip that slide there. Okay, so domain of composite functions. So the domain of f of g of x is the intersection of the domain of g and f of g of x. So let's talk about what that means here. And this is going to be mostly algebraic here. So let's talk about g. So if we're finding f of g of x, we first want to look at the domain of the inside function. Because if we have anything that is going to give us something that's undefined on the inside function, then when you can't plug undefined into the outside function, so it's not going to exist at that point, even if it looks like it should work once you simplify it all out. So let's talk about g. G is just x plus 1 squared. It's a quadratic. Are there any restrictions on that domain? Domain is all real numbers, right? So the domain for this is all real numbers. Okay. So we don't have to worry about our restrictions for g for this one because our domain is negative infinity to positive infinity. So now we want to look at f of g of x, right? Not just f, but f of g of x. So if we do the square root of x plus 1 squared minus 4. We're going to run out of time. There's no time. Okay. Well, we'll do this one and I'll show you what you got. Oh, the time is so short. Do I even want to do this one right now? Okay, we're going to stop because I want to explain what you got for homework, and time has gotten away from me. So, you're not going to do all of the homework because we didn't get to composite functions. So homework is going to be on Desmo's Classroom. So let me show you what it's going to look like. So, you'll just go to Desmo's Classroom, student.desmos.com. It should be assigned to you. I believe I've assigned it. And you're going to go to this one that says Domain of Inverse and Composite Functions. Okay, so let me show you what it will look like for you. It's going to tell you here your directions. Here, I'm going to tell you, it's a matching here. So what I want you guys to do, this card right here that says functions, you don't match it with anything. That's telling you what your f of x and g of x are. Okay, so tonight what I want you to do is I want you to match f of x, g of x, f inverse, and g inverse to their domains. Okay? So you do not need to do the f of g of x or the g of f of x because we haven't done those yet and you don't know what to do with them, right? So I want you to match f, g, f inverse, and g inverse to their domain. So like, for example here, g of x is just a line. It's all real numbers. So I would match g to all real numbers. Right there. F of x is going to be x is greater than 3. So I would match that here. X is greater than or equal to 3. And then if you've got that right for these, well, you got, and then you'll have to think about the domain. Sometimes there'll be more than one. So like for the g of x, g inverse is also a line. It's also going to be all real numbers. So some of these may only have one that goes with it. Some of them may have more than one. So you are going to do set 1, 2, and 3. If you look at the bonus set 1, bonus set 2, and bonus set 3, I realize that I made some that are too hard for us to do at this point because we need to learn something else first. So these are bonuses. You could still probably do it using Desmos if you want. But it'll be bonus points, not required. So only set 1, 2, and 3 are required, and you only have to do f, g, f inverse, and g inverse for me tonight. We'll finish up composites tomorrow because we ran out of time. Okay, ready? Good.